use whatever's available, use the fast loader or some other kit. So this also kind of feels a little dishonest because this is not really inherently useful because we're essentially densely encoding some very sparse information. And this is not what science is about. So there is an alternate approach where we embed on this insanely huge embedded images is another approach to this, where you take an arbitrary figure inside of your document and you encode it as way too many pixels. If there are no diagrams because you write some sort of math, then you can always embed a really tiny one somewhere out of the way. This too has some problems. Namely, it does mar your manuscript because you have to change the appearance of some of it in order to hit your byte target. This also is not terribly elegant, since this is academic work. We're starting from elegance here. So as part of this work, I settled on a much more elegant approach, which is called 100. That's presented in the bottom right, and it's every target you can look for hopeful. And here I'm just offhandedly discussing all the previous approaches that we described. 100 is basically the best. Here's how this works. So the PDF data structure is organized as a whole bunch of streams, followed by this cross-reference table, which tells you where in the document the various sections of the document are. And there's this magical space between the trailer and the end of file marker, where nothing really gets parsed. The file gets run.
Perfect for exfiltrating data.
So the file is right in its entirety. The parser will figure out where the cross-reference table is and use it to actually draw your document. And then the file is closed with this end of file marker for whatever archaic reason that I don't really understand. I guess when you're downloading this over some HTTP stream, it tells the parser to stop parsing. Yeah, or something. Anyway, so this little red rectangle is going to cram a whole bunch of random bytes into random because it resists compression and therefore elegant as hell. Also, nobody can really say that this is not inherently useful because randomness is an inherently useful thing, and so, do I have to do this myself? Well, no. I wrote a makefile that does it for me. And I guess I should also say that I have to figure out how to do some math inside the makefile to do this. That was the, I guess, second most bulk of this work. Figuring out how to do this computation in red, that $C $. That trash is essentially measuring the size of the document as it was emitted by the tech. We're going to call this mu doc, which is the smallest representable, which is the smallest quantity of bytes with which this manuscript is representable without changes. And we subtract the target number of bytes from the target number of bytes, the actual size of the manuscript as is, and generate enough randomness to produce a pad to stick right before that file marker. So this works great, as I showed you at the beginning of this presentation. But no presentation is complete without no talk is complete. Here's the meeting without a chart that goes up and to the right, so I measure the performance of the system. And by measuring the target document size from about 1 megabyte all the way up to 100 megabytes, and telling me how long it takes on a sweet-ass laptop, I'm showing that it's linear as hell, which is kind of awesome. The bottleneck of this process is sourcing randomness, which...
So you don't like randomness?
I love randomness. What are you talking about?
Like when I do cat/dev/be random, it runs out of randomness after a couple of seconds, and I do need to run them across to be able to get data. Yeah. It's actually a real problem for real research.
It is, and my second is actually all about that. Thank you for remembering that research. I don't remember if this is it, so no, it is not. So the second component of my work is how to actually get this submitted to SIGTBD, which is very challenging as it turns out, because PopCrap is a pile of PopCrap. So the content management system SIGTBD and many other conferences use is this hot CRP mess that's hosted on top of PHP and some SQL database, which is hosted on top of Apache, which you can talk to using the browser. And this is a deep hierarchy of poorly documented tools where upload limits apply. So when you want to submit a large document, and none of this infrastructure is designed to handle large posts, you have to go through every single one of them and figure out the right tweets to apply in order to get it to accept the thing. That's how it works. didn't actually work very well because I think we're still bounded by C-Cell's database limits. So I had a creative solution. And by employing my admin access to 6TBD, I just said that exactly. So I just figured it didn't work because I possibly needed to put it into GitHub also, which is a really terrible way to store PDFs, but
I know.
cool. So I will put it into.
You can just put it on the server directly. Yeah.
So this works. And any questions? Yes, yes.
I have a comment. I've now tried to actually view this on 2 different PDF viewers, including the one that comes with 1404. And
So thank you for noticing.
It-
This
bombs.
yes.
It cannot be rendered.
This does not work in the embedded viewer in Chrome. This also does not work in, I guess, the equivalent things.
I'm
It
using
does work in-
I'm using XPDF and I can't find the cross-ref for trailer dictionaries.
It's academic work. It does work in Safari. I checked. It also works in Firefox.
Maybe you found a
No,
bug.
I did not check it on Firefox. I guess it's just Safari and the native viewer. So this might be one of those Apple-only deals.
Yeah, so I had a question about how well this approach generalizes. I saw that it seems like you compute how big the PDF is now versus like how big do we need to make it to get it to 100?
Yes.
What if it's already over 100?
So that's a very good question. If I paper has an entire section that talks about the math of it, I define this quantity called mu doc, which is the smallest size which the final target can be. And by electing as a community to use the target uniform file size that is larger than any expected mu doc, we mitigate this problem quite effectively.
So this is very early promising work. I'm really impressed by the results. I was wondering, what do you see as the fundamental challenges of scaling this up to a gigabyte or maybe even a terabyte?
Popcraft is going to be the end of this.
Have you tried looking at placing the randomness in other places in the PDF document, like within comments?
I did actually. I spent a surprising amount of time figuring out how to do this work. And PDFs are annoying as hell to edit because, well, so actually, when you run PDF with tech, the output that you get is not actually human editable. It's a compressed stream, and the cross-reference table is just jumbled up in there. So basically, as part of the process, you can decompress it and then find a suitable place to put it in. You could put the randomness elsewhere, but you would have to update the cross-reference table. Putting it after the end of file marker does not suitable.
Is it possible to beat linear time?
Yeah, you could certainly use some pre-prepared randomness. That would help. I don't know, maybe there's some parallelisms to be had of some sort. You could also elect not to use UW random because that is arguably overkill. You could use less random quality, and I think it still wouldn't compress terribly well. So, cool. Last question.
Have you considered using your work as a content distribution network where instead of using random data, you can
We should have got why collaborations. Alright, I guess with that I'm going to thank myself. And I guess before we continue, I should note that the way SIGTBD works traditionally is we've got this stack of certificates. It's a big stack. So every author will get a certificate signed by the organizer, which I guess in this case is Sarah, because she didn't write a paper.
I had one in the pipeline.
Cool, well, you could submit it until like tomorrow at least.
No, I'll submit it next week.
And each and every single one of you will get a certificate of excellence in attendance, unless you leave early, in which case you'll be bumped down to a marginal certificate of excellence. So if you're a speaker, don't forget to hand Sarah one of these embossed fancy certificates.
So that I can decide what award you get
Yeah.
and also sign it.
And there's a lot of fields that are blank on there, so you're going to get a lot of interesting things on these certificates. And before you leave today, just pick up one of these blanks and fill it in yourself with a certificate of excellence. Thank you all.
Also, before we begin the next talk, I think I have a live stream going. If anyone with the conference.
Oh, cool. Can you record?
I can't. Yeah, it's recording. Yeah, live. So Ethan can tune in.
If you send him a link, I'm sure he will.
Well, I can't turn my computer.
Cool.
It's a live stream.
I'm going to put Kanye back on the screen.
Okay. Who's next?
Maybe you get the link.
All right, so who's the next speaker today?
Excellent.
Where are you?
It's on the website.
You need to do a hard refresh.
Are you gonna talk?
It was fantastic.
What are you on?
So next we have Stochastic Computing for Read Optimized Eventually Consistent Data Stores by Jonathan Behrens. The tweet abstract of this work is, in this work, we describe a new cache mechanism to radically improve read performance of an eventually consistent database without sacrifice. I just took the first 140 characters.
Sacrifice.
Can you check if there's a live stream of that? Go look up Google Hangouts, SIGTBD 2017. Live, maybe? Or maybe try YouTube. SIGTBD 17. Yeah, I would just go to YouTube. Try SIGTBD. Maybe I will stop it for a moment.